first topic being your physical reaction or physical changes. We have already discussed a little about chemical change. Now let's talk about it. So here are 5 characteristics of chemical reaction which will give us a hint that a chemical reaction has occurred. Collision theory, this is very important, as an unsuccessful collision means that the reactant particle just bounce off each other. 3 possible scenario which can take place when 2 particles collide. Hello and welcome students. I hope you all are doing good. So today we are going to start with your part 2 of chemical reactions. Part 1 we have already done, wherein we discussed what is collision theory and what are physical changes and chemical changes. If you have not watched that video, then go check that out. You will find the link in the description box below. So today in this particular video, we are going to cover the following topics. So we are going to discuss what is rate of reactions and what are the factors that affect the rate of reactions. These are the factors. By the end of the video, we are going to discuss investigating reaction rate, wherein we are going to discuss the 2 sub-points, measuring the change in mass of reactants or products and measuring the amount of gas formed. So let's dive into it. The first is rate of reaction. Now, what is rate of reaction? Rate of reaction means speed of reaction, how fast the reactants are consumed and how quickly the products are formed. Okay, so rate of reaction refers to how quickly reactants are consumed and products are formed in a chemical reaction. It is nothing but the speed of reaction. Okay, the following factors affect the rate of reaction. So what are the factors? Concentration of reactants in solution, pressure of reacting gases, surface area, temperature and catalyst. Now we are going to discuss each of these factors in detail. So the first is concentration of reactants in solution. So how does concentration of particles change the rate of reaction? More the number of particles, more the frequency of their collision, and hence the rate of reaction will be faster. Okay, let's understand this by the diagram. For example, this is your beaker 1 and this is your beaker 2. In beaker 1, the number of particles which are reacting to convert into product are lesser. Okay, so lesser amount, or I can say that low collision or number of collision will be less, right? If the number of collision is less, then it means that the rate of reaction will be less. Okay, the reaction will be very slow. But if we increase the number of particles in the reactant, the chances of them colliding will be higher. Okay, so the number of collision will be higher over here. If the number of collision is higher, it means more reactants will convert into product. Okay, and hence the rate of reaction will be greater. Now let's read this explanation using collision theory. That is why I'm saying that go check out the video. In the first part of this chapter, we studied about collision theory. Higher concentration result in more reactant particles in a given volume. The volume remains the same, but the number of particles are changing. Okay, the concentration is changing. As the concentration changes, the rate of reaction changes. More the concentration of reactant, more is the rate of reaction. Okay, then increasing the frequency of collision. This higher collision frequency means that there are more opportunities for successful collision per unit time. We talked about successful and unsuccessful collision also in part 1. Thereby enhancing the reaction rate. Now this is a graph between your total mass and volume of products and the time, okay, time taken. So when the concentration is less, then the graph will be something like this. When the concentration is high, then the time taken will be less, but ultimately the amount which will be formed or the product which will be formed will remain the same, right? So this you should know, the graph is important. Next, let's move on to the second factor which affects the rate of reaction, which is your pressure of reacting gases, right? For example, over here pressure is P1, over here pressure is T2. I push this piston down to make these particles come closer to each other, and hence I can say that more rate, or I can say more frequent collision will take place, and hence more product will be formed here, or I can say product remains the same, but speed of reaction will be higher. Okay, similarly over here you can see the graph. Low pressure, the graph will look like this. Higher pressure, the time taken will be less, but the amount of product will remain the same. Okay, now let's read. Higher pressure forces gas particles closer together, increasing the frequency of collision between them. This increased collision frequency result in a higher rate of reaction. I hope this is clear. Diagrams are making it very easy to understand, right? Over here, because the pressure is low, the particles are far apart from each other, therefore the collision will not be that frequent and hence the rate of reaction will be less. Okay, but in case of this ROR, which is your rate of reaction, will be higher because particles are closer to each other, they will collide more frequently and hence the reaction will be faster. Now, if you wish to make the notes of it, you may do so. Okay, this one also if you wish to note down. Okay, I hope you have noted this down. Here it is also written the amount of product is the same in both reactions, only the reaction rate or rate of reaction will change. Okay, same goes with this graph also, that amount remains the same, but this graph shows that how fast the reaction is taking place. Okay, now next let's move on to the third factor which affects the rate of reaction, which is your surface area of solid reactant. Okay, over here you can see that there is this one cube, okay, big block of cube, and if we try to react this with any solvent, then the surface area of this is lesser. But if we will powder this, or I can say if we crush this and we increase the surface area, then the reaction will be faster, right? So let's read. Effect on rate of reaction. Increasing the surface area of solid reactants lead to a higher rate of reaction. So if we use or if we try to dissolve a block of sugar in water, then it will be slower. But if we try to dissolve the sugar in powdered form in water, then the reaction or then the dissolution of sugar in water will be faster. Okay, why? Because in powdered form the surface area is more exposed to the solvent, right? Therefore, the reaction will be faster. Now, explanation using collision theory. A greater surface area exposes more reactant particles to the other reactant, leading to more frequent collision. This increased collision frequency enhances the reaction rate. Again, we'll discuss the graph. The graph is again between the time and total mass volume of reactants. Here, if the smaller surface area is used, it means big block of sugar is used, then the speed will be slower, or then the dissolution or the reaction rate will be slower. But if we are increasing the surface area by converting it into smaller pieces or powder, then greater surface area will be there and hence the more exposure, therefore rate of reaction or dissolution rate will be higher. So therefore this. Okay, if you wish to note down, you may do so. Okay, now let's move on to the fourth factor which affects the rate of reaction, which is change in temperature. So, if we provide temperature, basically we are providing the thermal energy, right? Temperature means we are giving or providing thermal energy to the particles. And what do these particles do? They absorb this thermal energy, they convert this thermal energy into kinetic energy, and they start moving faster. Okay, if they have more kinetic energy, means the rate of collision or they will be more number of collision and hence the rate of reaction will be faster. Okay, so if we increase the temperature, these particles absorb the thermal energy, convert into kinetic energy, they will collide more frequently, and then the reaction will increase. So higher temperature provide particles with more kinetic energy, so thermal energy actually, but then they convert with kinetic energy, causing them to move faster and collide more frequently. Additionally, more particles possess energy greater than the activation energy. What was activation energy again? Activation energy is the minimum amount of energy which is required by the particles to proceed with the reaction, okay, leading to more successful collision per second and a higher reaction rate. Okay, so more collision means reaction rate will be faster. Again, the graph. Next, let's move on to the last factor which affects the rate of reaction in your book, in your syllabus, which is your catalyst. Okay, so what is catalyst? Catalyst is that chemical compound or substance which itself do not take part in the reaction, but it just alters the rate of reaction. How? By providing a pathway with less activation energy. Okay, so let's read. Effect on rate of reaction. Using a catalyst increases the rate of reaction. Okay, why it increases the rate of reaction? because it provides a different pathway with lower activation energy, right? A catalyst is a substance that speeds up a chemical reaction without being changed or consumed. So it itself is not taking part in the chemical reaction. It is just providing different path for the reactants to convert into products, which is a shorter path. Okay, so if you'll see the diagram here, this is your activation energy, okay, when we are not using any catalyst. Okay, and if we are using a catalyst, you can see this hump. Okay, this is shorter in comparison to this one. So it is easier over here, and therefore the rate of reaction increases if we use a catalyst. Okay, and if we are not using a catalyst, then the rate of reaction is lower. Why? Because the activation energy required is more in this case. Okay, now let's read. The amount of catalyst remains unchanged because it is not taking part chemically in the reaction from the beginning to the end of the reaction, and it does not factor into the equation. Catalysts work by providing an alternative pathway with a lower, okay, this is important, alternative pathway with the lower activation energy. This is what I was talking about. This is your activation energy. Okay, then for the reaction to occur, this allows more reactant particles to possess the required energy, because now the activation energy window is less. It means that more reactants will be taking part in the reaction, and therefore the products will be formed faster. Okay, now what are enzymes? Enzymes are actually catalysts only, but they are biological catalysts. Okay, so enzymes are your biological catalysts that accelerate biochemical reaction in living organism. They work best at particular temperature, which is your optimum temperature, and pH ranges. Okay, this you should know. The graph you should know with catalyst and without catalyst. So with catalyst, the rate of reaction increases because it changes, or it provides an alternative pathway with lower activation energy, but it itself do not get consumed because it itself do not take part in a chemical reaction. Okay, it just provides a pathway, right? So please note down. Okay, I hope you have noted this. Now let's move on to understand what is investigating reaction rate. So basically, any reaction is occurring or taking place, and you have to check what is the rate of reaction, then what all things we can. So let's first understand. To find out the rate of reaction, we need to monitor how quickly the reactants are consumed or how quickly the products are formed. Okay, this is what rate of reaction meant, right? To investigate the rate of reaction, we can employ various techniques, including, okay, these techniques we are going to talk about, but before that, let's understand what is the formula to calculate rate of reaction. So what was rate of reaction? Everything is in your definition only. What is rate of reaction? It is how much of change in concentration is taking place per second or minute, whatever unit of time we are considering. Okay, so change in mass or weight, okay, change in mass of reactant also you can take, or product divided by time, okay, per time. So this becomes your rate of reaction. This is how we are going to calculate your rate of reaction. Now let's move on. So here, measuring the change in mass of reactant and product. Okay, so how will we measure that what is the change in mass of reactant and product when the reaction is taking place? Okay, so what do? We record the masses at regular interval. You can see this setup. For example, any reaction is taking place, we put a cotton plug over it so that no mass is exchanged from the surrounding, and it remains intact, and we can find the result with accuracy. Okay, so here we have to monitor in every 1 minute, 2 minute, or 5 minute, whichever reaction we are taking accordingly. So in, like, for example, every 1 minute, what is the mass which it is showing, the scale is showing. Okay, then we will plot a graph between time and the amount of reactant, or yes, the amount of reactant and time. We will make a graph, and this is how we will find out the rate of reaction. So this is how we measure the change in mass of reactant. Close the mouth of the flask with cotton wool to let gas out, but to prevent any substance spilling out. Okay, so this will ensure the accuracy of our using this technique or investigating. So this is how we are going to measure the change in mass. Now let's check how we are going to measure the amount of gas. This is going to be your setup. So here we are going to use a gas syringe. Okay, this time we are going to use a gas syringe. So any amount of gas which is being evolved, it will come in this gas syringe. Okay, and here you can see the scale is also present, so we can calculate the volume of the gas which is being produced. Again, the same time, same thing, that we have to check, we have to monitor the time and the volume of gas which is being collected over here. So use a gas syringe connected to the reaction flask to collect gas. The syringe has volume markings on it. Here you can see the markings. We can identify the volume of gas produced, record gas volume at specific intervals to determine its production or consumption rate, and plot it on a graph. Okay, very easy. This is almost the same. Here we are calculating the mass or the weight, and here we are going to calculate the volume of gas which is in the reaction. Right, same formula we are going to use. Volume of gas produced divided by time taken. The graph will be between your time on x-axis, and on y-axis will be your volume of gas, and then you'll plot the graph and you'll get the answer. Okay, or this is how you calculate the or measure the amount of gas formed. So here we come to an end of your part 2 of chemical reaction. I hope it helped you to understand the things. If you have any doubt, feel free to comment down below and I'll get back to you. I'll be coming with the part 3 really soon, and we are going to try a lot of questions, so make sure that you are making notes of it, and I'll see you very soon. Till then, keep learning and enjoy. Thanks for watching, and I'll see you in the next video. Till then, don't forget to like, share and subscribe to our channel.